Greetings, YouTubers. Today we're going to discuss the reciprocal, also known as the rational parent function, y equals 1 over x. Take all these x values, plug it in. So we get negative 1/10, negative 1/5, negative 1. Then we get negative 2, negative 8. We cannot divide by 0, so that's undefined. Then we get 8, 2, 1, 5, 1/5, and 1/10. So our picture, when you graph this, is going to look something. Maybe my pen will work. Oh no. Sorry. One sec. Alright, sorry about that. Technical difficulties. Anyway, so here we have our numbers, and we're going to just plot those so that it's going to look like this. So we got negative 1/10, negative, all that stuff goes down here, and then we got the positives going up here. Whoa, don't cross the axis. We also have a horizontal asymptote at y equals 0, so that's going to be this horizontal asymptote, that's why I don't cross that. And my vertical asymptote is at x equals 0 right there. Our y-intercept, don't have one, because my graph never crosses the y-axis. And x-intercept, I don't have one, it never crosses the x-axis. And then my domain is connected with the vertical asymptote. So we got everything but 0, so we're going to say negative infinity to 0 union 0 to infinity. That's an infinity's promise, I promise. And then same thing horizontal there, negative infinity 0 union 0 to infinity. I saw infinity symbols. All right, that's that. Now an asymptote is a line that the graph gets really close to as x gets bigger and smaller. So if we go back a second, as x gets bigger and bigger and bigger, this graph is getting closer and closer to that asymptote. Same thing, as x gets closer and closer to 0, this line is getting closer and closer to this asymptote. So that's what that means. Here we have our rules for transformations. The a, whether it's a big number or a small number, will change whether it's a vertical stretch or compression. If it's a negative number, big or small negative, it flips across the x-axis. So, if it's normally up here, then it's going to be down here. And then if it's normally down here, it's going to be up here. K, go up or down. H, left or right. And it's opposite for the H. Remember that. All right, so we'll do a couple examples and then I'll let you go. Our first two transformations, down 5 and left 3. So instead of my vertical asymptote being at x equals 0, now it's at x equals negative 3. And instead of being at y equals 0, now it's at y equals negative 5.
Good afternoon, students. Just a reminder, today is Wednesday. Those students
Sorry,
have been assigned
vertical
to
asymptote.
school. You have less
This is
than
my
5
domain.
minutes to make it to the
So negative infinity, it's
Use
negative
that meal
3
time,
union
4:30. Those
negative 3
students
to
who are assigned to
infinity.
Wednesday school, please
Negative
report
infinity to
immediately.
negative
Have a
5
blessed day.
union negative 5 to infinity. All right, the last thing is we need to find our x and y-intercept. So for our y-intercept, we're going to plug 0. Let's say plug 0 in for that number right there. So we get y equals 1 over 0 plus 3 is 3 minus 5. So that's going to be negative 4 2/3. So that's about 0 comma negative 4.6-ish. Remember, 4 2/3 repeats on forever. So 0 comma negative 4.6 is about right there. All right, and remember, it's supposed to still look like this, so looking good so far. The next thing is we're going to plug 0 in for the y. So 0 equals 1 over x plus 3 minus 5. And this one stinks. We add 5, and we got to solve for x. So I multiply both sides by x plus 3 on both sides now. Remember that. Then distribute. So I got 5x plus 15 equals 1. Subtract 15. Whew, almost there. Divide by 5. And x is negative 14/5, or negative 2.8. So negative 2.8 comma 0. So negative 2.8 is about right there. And as we can see, we connect our dots. Gets really close to that asymptote. Didn't quite touch it. Remember, we got two parts, so 9's there, and the other line is up here, and do our best there. If you want to get exact values, plug in, negative 5, negative 6 in for x, and that'll give you the exact point. But on this, just do our best. We're not looking for exact points. Okay, I want to go over the transformations, and I'll let you try it. Number 3, transformations, up 2, and then my negative sign reflects across the x-axis. All right, here's a chance to pause, work on it by yourself. Okay, so it went up 2, so that means instead of being at y equals 0, now it's at y equals 2 for my horizontal asymptote. My vertical one didn't change at all, right? I didn't go left or right at all, so that stays the same, x equals 0. So my domain is still negative infinity to 0, union 0 to infinity, and my range is everything but 2. So negative infinity 2, union 2 to infinity. I don't have a y-intercept, right? It never crosses that, so that's a nunner. And then for my x-intercept, plug in 0 for y. So let me get my pen here. 0 equals negative 1 over x plus 2. Subtract 2. I got negative 2 equals negative 1 over x. Then we're going to multiply by x and divide by negative 2. And that's just solving for a variable. So I got 0.5 comma 0. So that means my new graph is right there. But wait, oh, well, I'm supposed to be up here. No, remember it's flipped. So, oh, there we go. We're there. And we're there. Okay, that's it, guys. That's all I wanted to go over. Try number 4 and 5. Number 4, the only difference is you got 8 over x. It's going to look exactly the same. Your numbers are just different. Everything else stays the same. And then my transformation rules, this is going to go left 5, down 6, and the negative reflects. Okay, give that a shot. We'll see you next time. Bye-bye.